Hey everybody, this is Larry. This is day 12 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. 75 sort colors. Given a nums with an object colored red, white, or blue, sort them in place so that, okay, oh yeah, and without the sorting function. Yeah, I think this is called the Dutch flag algorithm. Unless I'm mixing it up. Yeah, Dutch flag algorithm. The idea here is, so yeah, I mean, obviously you can do some sort of funky sort, and you can actually even do just like a counting sort. But here the follow-up, you can see with counting sort is actually pretty straightforward. You can do it on two pass. One just to do the counting for 0, 1, and 2, and then the second pass to update, right? Not that much of an issue. But if you want to do it one pass, which is really not a big deal usually, then you want to do something called the Dutch flag algorithm. The idea here is kind of like kind of like a slide, not sign, but the idea here is just to use the idea here is to create an invariant such that certain things are always true. So the way that we want to do it is that obviously by sorting, you want it to be in 0, 1, and 2, right, in that order, right? So then now we can just begin by creating the borders of which, of which these are true, right? So then maybe we have a 0, 1 border and maybe a 1, 2 border. And I want to say that just to kind of, my head is a little bit weird today. I ran 8 miles today, a lot of sprints, so I don't know, I'm a little bit tired again. I'm here back in New York, by the way, in case I didn't mention it. But the idea here is just to, I mean, and also to be honest, most of this is off my head, so I may be a little bit sloppy, I may be a little bit off, so please forgive me. I want to, do this as live as possible to show that, it is possible to know this, and I don't think I memorized these things, because if I did, then I don't think I could be able to explain it, because, but I do remember the idea of it, right? The idea is more important than remembering patterns and implementations and so forth. So here we have 0, 1 and 1, 2. Maybe we put it at the end, right? And the idea here, maybe I -1. And the idea here is that you're separating an array, so maybe you have a long array. I'm just going to put in X for elements. And then now here you have two border things, 0 and 1s, right? And 1s and 2s. Technically 1s and it's not even that. The 1 part is not accurate, but the idea here is that everything before the 0, 1 is going to be 0. Everything after the 1, 2 is going to be 2s, right? So everything here behind that is going to be 2s, and this is going to be 0s, and then everything in between is just unsorted with stuff being maybe a 1. Yeah. Yeah, and 1s can go anywhere in the middle, but in the end, when you put all the 0s in the right place and all the 2s in the right place, then the 1s will all naturally be in the right place. So okay, so then now with this in mind, and this is the invariant that we're trying to keep, right? Everything before the 0 border is going to be 0s, and everything behind this border is going to be 2s. And then now we can go from left to right in one pass, right? And if num sub I is equal to 0, then we want to put it into the 0, 1 group, right? So then now we go v1, and this is the next number that is going to, because this is the border, this is the next number that we're going to update it. So then num sub I and num sub 0, 1 is, we swap them, right? And then 0, and then we increment, because that means, because then now what we know is that num sub 0, 1 is going to be a 0, right? Because this is already 0, so you know. And num sub I could be whatever it needs to be. Maybe this is not a for loop though. But yeah, but then now you continue, right? Or maybe this is going to be I is less than 1, 2, actually. The reason is because after that, everything is already sorted, so, or to be 2s, right? So yeah. I think this is okay. Maybe I'm trying to double check in my head what the details are. Like, but something feels a little bit sketch, but yeah. I don't know. If num sub 1 I is equal to 2, then we do the same thing. We swap it with 1, 2. And once again, num sub 1, 2 then now will be a 2 because we swapped it with I. And 1, 2, we increment by 1, and then we continue. The reason why we can continue without incrementing I is that now we have a new number and then we can check what it is. Otherwise, then num sub I is going to be 1. And if num sub I is going to be 1, then we can just increment it. I think this should be good. But yeah, let me just run it then. Ooh. Oh, I guess I should. What? Wait, how does this output? How does this go out? Oh, this is not +1. This is -1. Whoops. Silly mistake. Yeah, I feel like something is missing in mine. That's why I was like a little bit weird. Because, okay, so if I is 1, then we increment by 1. So, okay, so we can go through this. I feel like I am missing something a little bit, clearly. But that's okay. Now you know that I'm not lying when I say I don't memorize it, because otherwise I would just know it. But okay, so the 2 we sorted to the back, right? So then now this is a 0. We now see it, so then now we increment. So then after loop, there's gonna be actually I guess I could just print it out. A little bit lazy. Okay, so after maybe not here, maybe after here, so that's more incremental. Okay, that's what I expected. Okay, looks good, looks good. So this is a so it should be here, but then something is weird here. All right, let's also print 0, 1 and 1, 2. 0 and 5, 0, 0 and 4, right? That's good. 1 and 4, 2 and 4. Oh, do I have to do something with? Am I doing I incorrectly? Maybe I'm doing. I think maybe here we need to increment I because it is doing the same thing. Yeah. Okay, there we go to fix at least this one, because we didn't increment I, and I think it's just doing some funky things afterwards. But okay, so now this is 0, I 0, 0, 0, 2. The 2 we push it to the back, and then now it's a 1. 1 we increment. Okay, that sounds fair. And now we see this Z. Oh, this should be yeah, because 1, 2 is the number that doesn't have it, right? So okay, there you go. And we can also just like bang out some random things. Oops, maybe not that random. Okay, so let's give it a submit. Hopefully I didn't make a mistake. But yeah, that's pretty much it. 34-day streak. The invariant is the important part about this problem. Is just to keep the 0, 1, and if you have a strong sense of the idea and the invariant, then it makes it easier to debug, right? Because I have 2 bugs that you may recall. One is that I forgot to increment I plus 1, but that's because I was just thinking, okay, well, if I is before 0, 1, it doesn't even make sense because 0, 1 is already moved, right? So you can think about 1, 2 subtracting, so this is already doesn't go through that. So that's a easy bug. And this is less than equal to, because if I gave it a more deeper dot, 1, 2 is the number that you can't swap into. So that means that if it's Leetcode, then you have to check it, because it may go with 0, 1. But yeah, this is basically one pass, right? And only use constant extra space, 2 variables, and a lot of swaps. So yeah. That's all I have for this one. I think it seems like I've solved this like 4 times, so I don't know. I don't know if it's a well-known algorithm, to be honest. Let's take a look. Did it with? Oh. To be honest, I feel like even though I did it here, maybe this looks cleaner. But yeah, I think I did not know this algorithm before Leetcode, so I definitely was trying to come up with something way back when. But I don't know, is it that important? I don't know. Is it that well known? Apparently people know it. I don't know what to think about it. I mean, it's just very specific, so it's a little bit for interviews, I don't know. I've never seen it on an interview, but I don't know. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.